On our next problem, 2x plus y minus z equals 10, negative x plus 2y plus 2z equals 6, x minus 3y plus 2z equals 15. We need to first make our augmented matrix. Once we have our augmented matrix, I need to get the matrix in reduced row echelon form. So in order to get it in row echelon form, the first thing I need is a 1 in the upper left-hand corner. The ways to get a 1 are to change two rows if you already have a convenient one, or to multiply the row by the reciprocal. If I multiplied by the first row by the reciprocal, I would get a fraction right away, because 1 divided by 2 is a half, which is a fraction. So I'm going to look in the first column to see if I have a convenient one, and I do. So I can take row 1 and row 3 and interchange the two rows. Row 2 stays the same. And row 1 and row 3 switch places. So I have successfully got my 1 up in the first row, first column position. Okay, good job. Now I want zeros below it. So the next step is to get zeros below it. The rule to get a 0 is to take the opposite sign. So when I'm looking at the -1, the opposite sign of -1 is +1 times row with the 1 in it. In this case, the row with the 1 in it is row 1. Add it back to the row. At the same time, this is the only step that really can do two numbers at the same time when you're trying to get two zeros in the first column. I can also try to get this 2 to become a 0. The way to get a 0 is you take the opposite sign of +2, which is -2, times the row with a 1 in it. And the row with the 1 in it in this case is row 1. Add it back to the row and put it back in the same row. So what row stays the same? In this case, the first row is the row that stays the same. To get the green row, it's row 2. I'm going to come off to the side of my paper, and I'll do it horizontally. So 1 times row 1 plus row 2. Let's see. So I have 1, -3, 2, and 15. -1, 2, 2, and 6. I guess this one's vertically, isn't it? 4 and -9. So that gets me 0, -1, 4, and -9 when I do the operations. And then I'll do the other one horizontally. So that's -2 times row 1 plus row 3. So row 1, that's 1, -3, 2, and -15. Notice I'm always using the matrix, my previous matrix, when I'm using the rows, because they change every time, so you make sure you're using the correct one. So -2 plus 2 is 0. Yay, no surprises there. That's what we were hoping to have happen. 6 plus 1 is 7. -4 minus 1 is -5. +30 plus 10 is +40. So I can put 0, 7, -5, and 40 in my row 3. Okay, time for a progress report. Do I have a 1? Check. Do I have 2 zeros? Check, check. Do I have a 1? I don't. So the next thing that I'm working on is to try to get a 1 right here in the second row, second column. So what is the rule to get a 1? I've already used to switch two rows. That's usually used in the first step. In this case, I'm going to multiply the row by the reciprocal. The reciprocal of -1 is 1 over -1. Times it by row 2 and put it back into row 2. So which rows stay the same? Well, row 1 and row 3 will stay the same for this step. And I'm multiplying the row 2 by its reciprocal. If you don't want to think of it as 1 over -1, you can just think of the whole row divided by -1. 0 divided by -1 is 0. -1 divided by -1 is +1. 4 divided by -1 is -4. -9 divided by -1 is +9. Okay, progress report time. Do I have a 1? Check. Do I have a 0? Check, check. Notice I didn't mess those 1s and 0s up if you do it in the right order. If you're just kind of trying to be a little bit creative and not do it in the same exact order every time, you can accidentally mess up the 1s and the 0s you've already got. So make sure you do it in the right order using the correct steps that I've given you, okay? So I've got the 1s and the 0s and the 1. So the next thing I'm working on is the 7. And the 7 wants to become a 0. So I need it to become a 0. So go back into your rules and see how we're going to get a 0. The rule to get a 0 says you take the opposite sign. The opposite sign of 7 is -7. Times it by the row with a 1 in it. Which is the row with the 1 in it? Well, because I'm looking in this column, the row with the 1 in it is row 2. That's the row that has the 1 in it down the diagonal. So that's -7 times row 2 plus row 3, put it back into row 3. This is the one where you have to do a little bit of work on the side of your paper, either vertically like I'm doing now or horizontally, either one. I'm going to take -7 times row 2, that's 0, -7, 28, and -7 times 9 is -63, and add it to 0, 7, -540, which gets me 0. 0, okay, that 0 should be no big surprise. We were hoping that that was going to happen. 28 minus 5 is 23. -63 plus 40 is -23. So on the next matrix, row 1 and row 2 stay the same. And row 3 becomes 0, 0, 23, and -23. Okay, let's do our progress report. I have a 1. I have a 0, 0, yes. I have a 1, yes. I have a 0, yes. So the next thing I'm working on is the 23. And the 23, in this case, needs to become a 1 so that I can have my matrix in row echelon form. In order to get a 1, the rule says to get a 1, I'm going to take the reciprocal. The reciprocal of 23 is 1 over 23, and multiply it by the row 3, put it back into row 3. So row 1 and row 2 stay the same again. Make sure that when you're rewriting these rows, you're very careful not to drop a negative anywhere. When I multiply by 1/23, sometimes that's hard for students, so instead you can just think of it as divide by 23. 0 divided by 23 is 0. 0 divided by 23 is 0. 23 divided by 23 is 1. -23 divided by 23 is -1. Now we can't write divide by 23 because there's no such thing as matrix division, but we can write it as 1/23 multiplied by, and then just think of it as divide. Now, using my little progress report, I have a 1, I have a 0, 0, I have a 1, I have a 0, I have a 1. I am now happy with the way my matrix looks. It's in row echelon form, so I can now rewrite it. X minus 3y plus 2z equals -15, y minus 4z equals 9, and z equals -1. Now let's change those into solving for x, y, and z. So in order to solve, I'm going to move the 3y, so I have x equals 3y minus 2z minus 15. Notice that the 3y and the 2z changed signs, but the -15 didn't because it was already on the right hand side. For y, I'm going to move the 4z over. It's going to go from -4z to +4z. Notice the 9 stays positive. And then z is already solved for -1. So I'm going to use some back substitution. I already know my z answer. To solve for y, I'm going to take 4 times z plus 9, but my z is negative 1, so that is y is equal to negative 4 plus 9, so y is equal to 5. For x, I have 3 times y minus 2 times z minus 15, where my y is equal to 5, my z is equal to negative 1, and I have x equals 15 plus 2 minus 15, which is 2. So my ordered triple is 2, comma, negative 5. So my ordered triple is 2, comma 5, comma negative 1. And this concludes our lesson on matrices.